Okay, this problem is, imagine a 4 kilogram trash can. The trash can is disgusting, so you tie a string to it and pull it on the string with a force of 50 newtons. The force of the kinetic friction of the trash can while it slides is 30 newtons. The trash can slides across the ground for 10 meters. What is the work done by each force acting on the trash can as it slides across the ground? What is the net force acting on the trash can? What is the speed of the trash can after it has slid 10 meters? So the first thing I did was I drew what was going on. There's a trash can right there. It slid 10 meters and stopped. And there's the ropes attached to trash cans. So we know that the force acting on the trash can is 50 newtons. We know that the kinetic force is 30 newtons. The next thing I drew was a free body diagram, and these are all the forces that I'm going to answer in this problem. So we start off by using the workforce equation, which is right there. And I figured the work done by tension is, we figure out that it is work equals 50 newtons times 10 meters times cosine 0, which gives you a work of plus 500 joules. And that is for work tension. Work done by friction is, you do, using the same formula, you do work 30 newtons times 10 meters times cosine of 180, gives you the work of negative 300 joules. Then work done by gravity, I figured out the force of gravity is 4 kilograms times 9.8, which gives you 39.2 newtons. So you use the work formula, and it is work equals 39.2 newtons times 10 meters times cosine of 90 degrees gives you work equals 0 joules. And to figure out the work net, you do plus 500 joules minus 300 joules plus 0, and that gives you 200 joules. And to figure out the work net, this is my equation I did. And we end up figuring out that the final velocity for the trash can at the end was, the final velocity was 10 meters per second, and that is how you solve this problem.